Hello students, myself Dr. Divya, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will discuss the problems on temporary and permanent hardnesses in units PPM. So expression of units for any hardness, whether temporary or permanent, will be in given in the form of equivalence of calcium carbonate. So it is calculated from degree of hardness, how much hardness is present in that particular water, that is given by weight of the hardness causing salt. For example, bicarbonates or bicarbonates or sulfates or chloride salts of calcium, magnesium are majorly responsible for this hardness. So their weight is taken by their molecular weight of hardness causing salts. So these are the hardness causing salts and multiplied by molecular weight of calcium carbonate to get equivalence of calcium carbonate, that is generally expressed for. So there are a lot of salts like this present, so that is causing hardness, like calcium bicarbonate, magnesium bicarbonate, calcium sulfate, chlorides, etc. So their molecular weights are these, so like we have to either mark up or calculate during the problem solution. So these are the equivalence weights of that particular hardness causing salt, and the multiplication factor is done by 100, which is the molecular weight of calcium carbonate, divided by molecular weight of that particular hardness causing salt. So then we have these relationships of units of hardness. If you see, there are different units that are used for expressing this hardness depending on their application. So it is like 1 ppm is nothing but 1 mg per liter, milligram per liter. So that is equal to 0.1 degree French, and which is also equal to 0.07 degree Clerk. So whenever we want to calculate in degree Clerk, we have to multiply with 0.07 of that particular ppm or 1 mg per liter value, so that we get in degree Clerk, and for the degree French we have to multiply with 0.1 degree French. So now we are calculating or expressing in this session, we will be expressing in ppm. ppm, it's nothing but parts per million. So those many parts are present per million of solvent molecules. So that is the clarity we get. So then 1 degree Clerk is equal to 1.433 degree French and 14.3 ppm, and that is also equivalent to 14.3 milligram per liter. Similarly, 1 degree French, if you see this cross multiplication, we can understand that 1 degree French is equal to 10 ppm, which is also milligram per liter and is equal to 0.7 degree Clerk. So these are the different units that are used for expressing the hardness. So now we'll jump into the problems. A sample of water is found that contains the following analytical data in milligram per liter. So milligram per liter, they have given in milligram per liter, which is equal to ppm. So all these are in ppm. The values given are in ppm. So magnesium bicarbonate is 73 ppm, magnesium sulfate 40, calcium bicarbonate is 81 ppm, and calcium chloride 111, and magnesium chloride is 95 ppm. Now what we have to do? Calculate the temporary and permanent hardness of water in ppm or parts per million. So for that we will be using the formula. Degrees of hardness, it is equal to weight of hardness causing salts, that is, for example, 81 divided by its molecular weight into 100 to get the equivalent amount in the form of calcium carbonate. So before moving to that, we have to put it in the table. Like we have 1, 2, 3, 4, 5 salts, and take their weights in another column, 73 and 111 for calcium chloride. Calcium carbonate is 81 ppm, then 40 is for magnesium sulfate, and magnesium chloride is 95. Now we have to do like put the molecular weights molecular weights of those corresponding salts. And now multiply these divide these molecular weights with the 100, that is the molecular weight of calcium carbonate, and multiply with this weight, that is amount of hardness causing salt in milligram per liter. So all these are in milligram per liter or ppm. Everything is in milligram per liter. We get these values in milligram per liter. So whatever the amount we get is nothing but the amount equivalent to calcium carbonate present. So we are converting into calcium carbonate by dividing with 100, the molecular weight of calcium carbonate. Now we will calculate the temporary or permanent hardnesses of that particular water sample. So what are the causing salts? Bicarbonates are responsible for temporary hardness. So how many bicarbonates are present here? 1 and 2. So this is temporary hardness, and calcium bicarbonate is temporary hardness. Chlorides and sulfates are responsible for permanent hardness. So how many are present here? This is permanent, this is permanent, and this is permanent. So accordingly, we have to take those corresponding values and use it for the calculation. Now temporary causing hardness is by magnesium bicarbonate and calcium bicarbonate. So 50 plus 50, that is giving to 100 ppm. 50 plus 50 together is forming 100 ppm of temporary hardness is present, and permanent hardness is magnesium chloride, magnesium sulfate, and calcium chloride are responsible. So 100 plus 100 and 33.3 are added together and we get 233.3. If we see this sample, there is a lot of permanent hardness that is present, so we have to go for the treatment after the removal of temporary hardness. Treatment with the chemical agents or ion exchange or any other reverse osmosis to be used to remove this permanent hardness. So next is a sample contains 4.8 milligrams of calcium sulfate per liter. So calculate the hardness in terms of calcium carbonate. So we have only calcium sulfate that is present, which is 4.8 milligram per liter. So this is the value we have. The sulfate is responsible for permanent hardness. So we will first calculate that weight of the hardness causing salt by molecular weight into 100, and we get 4.8 into 100 by 136, we get 300 mg per liter or 300 ppm. So this is 4.8 and 300 ppm, which is nothing but mg per liter is nothing but ppm. So this is the permanent hardness that is present. Only one salt is present, so that is responsible for permanent hardness. Next, calculate the temporary, permanent, and total hardness. Temporary hardness, permanent hardness, and total hardness of in sample in ppm, having the following composition. Calcium bicarbonate is 4 ppm, magnesium bicarbonate is 6 ppm, and magnesium sulfate is 10 ppm, calcium sulfate is 8 ppm. So these sulfates are responsible for permanent hardness. Sulfates are responsible for permanent hardness, and bicarbonates are responsible for temporary hardness. So now we take this formula again. Degrees of hardness is equal to weight of hardness causing salt is nothing but the concentration that is given by molecular weight of the hardness causing salts into 100, that is nothing but the molecular weight of calcium carbonate. So the temporary hardness is due to bicarbonates of calcium and magnesium salts. So temporary hardness is equal to, what is the bicarbonate that is present? Calcium bicarbonate 4 into 100 by 162, which is the molecular weight of calcium bicarbonate, plus 6 into 100 by 146, which is the molecular weight of magnesium bicarbonate. So that we will get in 6.58 ppm. This is the value we get for the temporary hardness. Then permanent hardness is due to calcium sulfate and magnesium sulfate. Sulfates are responsible for permanent hardness. So we calculate for the sulfates. Magnesium sulfate is 10. This is due to the magnesium sulfate, and 8 is because of calcium sulfate. So 8 into 100 by 132 plus 100, 10 into 100 by 120 is the molecular weight for the magnesium sulfate. So we get, after recalculation, we get 14.21 ppm. So this is the permanent hardness we get, and this is the temporary hardness we got, and we have to calculate the other one, that is total hardness. So total hardness is combination of both the temporary and permanent hardness that contributes to the total hardness. So we get 6.58 plus 14.21 is nothing but 20.79 ppm. So the total hardness is 20.79 ppm that is present in that particular water sample. So if we see this, even in this sample, it is like sulfates are very high in concentration, so the permanent hardness is high, that has to be removed only upon the treatment. Next is calculate the temporary, permanent and hardness of water in ppm having following composition, wherein calcium bicarbonate is 4 and magnesium bicarbonate is 6 ppm, and magnesium sulfate is 10 ppm, calcium sulfate is 8 ppm, and sodium bicarbonate is 3 ppm. So if you see this, they have also given the sodium bicarbonate which is present in water. So what is the sodium bicarbonate does? When sodium bicarbonate is present really in water, temporary hardness increases at an expense of permanent hardness, but the total hardness remains same. So it means that whenever there is a presence of bicarbonates of sodium bicarbonate is present, the temporary hardness will increase just because of bicarbonates that are present, but the total hardness remains the same. That we will see in the calculation, so that we get more clarity on this. So total hardness, what is the total hardness that is responsible from the bicarbonates of calcium, magnesium and sulfates of magnesium and calcium. So now we will calculate the total hardness. 4 into 100 by 162, this is calcium bicarbonate and magnesium bicarbonate. This is the molecular weight of magnesium bicarbonate, and 136 is the magnesium calcium sulfate, and 120 is the magnesium sulfate. So overall we get a total hardness of 20.79 ppm. So temporary hardness is increasing. So how is it increasing? It is increasing by 2. So 4 into 100 by 162, that is calcium bicarbonate, and 6 into 100 by 146, that is magnesium bicarbonate, and 3 into 100 by 2 into 84, that is because of sodium bicarbonate that is present. So because of this, there is an increase in the temporary hardness, so we get a concentration of 8.37 ppm, which is responsible for the temporary hardness that is caused by the sodium bicarbonate. So next, permanent bicarbonate we have to calculate. So we have to take into consideration the total hardness and then calculate the permanent hardness that is responsible after calculating for the sodium bicarbonate if it are present in the sample. So permanent hardness is after rearrangement of equation we get total hardness minus temporary hardness. So that is 20.79 minus 8.37, which is equal to 12.42 ppm. So this is the permanent hardness that is present. So 12.42 ppm in that particular water sample. So we are even considering the temporary hardness that is contributing from the sodium bicarbonate. So this is how we have to calculate whenever the sodium ions are given in the question. Next, calculate the temporary and permanent hardness of water which contains calcium ions is 200 ppm, magnesium ions is 96 ppm, bicarbonate ions are 976 ppm, chlorides are 146 ppm, and sulfate is 96 ppm, and sodium is 112 ppm. So they have given anions and cations. They have given cations and anions, not the whole salt. So the total hardness is just because of the calcium and magnesium ions that are present in the particular sample, and the temporary hardness is due to the bicarbonate that is present, and the permanent hardness due to chlorides and sulfates. So this sodium does not contribute to any hardness, no hardness due to this sodium salts. So now total hardness is taken by 200 which is because of calcium ions and magnesium ions is 96. The cationic species that are contributing to this hardness, and 100/40 is the calcium ion molecular weight, atomic weight, and 100/24 is equal to 900 ppm. So whenever they are giving only ions, ionic state, we have to take their atomic weight, not the molecular weight, because the whole formula is not available for us. That can be either magnesium chlorides or magnesium sulfates or bicarbonates. It can be in either form. So whenever there is huge amount of bicarbonate that is present, it means it is present along with the cations, but they have split it into the cations separately and anionic species separately. So bicarbonate concentration is high, it means that it has high temporary hardness. So temporary hardness is calculated from 976 into 100/2 into 61. So that is giving rise to why we are taking 2, because there are 2 ions that are present that can be contributing to the bicarbonate, calcium and magnesium ions. So therefore we are taking into consideration 2 into 61, that is the bicarbonate atomic weight, and it is giving rise to 800 ppm. Now we have to calculate the total hardness. So total hardness is like total hardness, we can substitute in this, like 900 minus temporary hardness will give rise to permanent hardness. The permanent hardness can be calculated from this. So that is from the responsible from the chlorides and sulfates that are present. So 900 minus 800 will give rise to 100 ppm. So this is the permanent hardness that is contributing to the hardness of that particular water sample. Next, calculate the temporary and permanent hardness of a sample of water containing impurities. Magnesium bicarbonate 73 ppm, calcium bicarbonate is 162 ppm, and calcium sulfate is 136 ppm. Magnesium chloride is 95 ppm, calcium chloride is 111 ppm. Sodium chloride is 100 ppm, silicon dioxide is 100 ppm. So if you see this, they have given lot of salts that are present in the particular water sample, but still sodium chloride and silicon dioxide has no role in the hardness contribution. So therefore we can omit those in the calculation. So the concentration of impurities has to be converted to the calcium carbonate equivalents to get the hardness. So temporary hardness is due to bicarbonate ions that are present. So magnesium and calcium ions are responsible for the temporary hardness. So 73 into 100/146 is the bicarbonate of magnesium. Then 162 is the concentration of the amount of hardness causing salt, calcium bicarbonate, by into 100/162 is the amount or the molecular weight of calcium bicarbonate, and we get 150 ppm is the temporary hardness that is present in that particular water sample. So then permanent hardness is due to chlorides and sulfates, chlorides and sulfate ions. So sulfide ions. So this 136 into 100/136, it is due to the calcium sulfate that is present in that particular water sample, and 95 is the magnesium chloride. So 100 into 95 is again the molecular weight. So here the molecular weight and the weight that is causing the hardness is similar, but in other cases we have to calculate the molecular weight and only then substitute. So then 111 is the calcium chloride into 100/111, that we get ultimately 300 ppm, that is causing the permanent hardness. So total hardness, now total hardness is equal to temporary plus permanent hardness. Temporary plus permanent hardness will give the total hardness. 150 plus 300 is like 450 ppm is the total hardness that is present in that particular water sample. So even in this sample, the permanent hardness is very high because of a large amount of chlorides and sulfates present. So we have to go for the treatment by equipment or chemical agents. Next, calculate the temporary and permanent hardness of a water sample containing bicarbonates of magnesium 73 ppm. 7.3 ppm. So next is the calcium bicarbonate 16.2 ppm, calcium sulfate is 13.6 ppm, and magnesium sulfate is 9.5 ppm. and calcium chloride is 13.6 ppm. So how many are present? Like these two are responsible for permanent hardness and these two are responsible for temporary hardness. So now we have to calculate the concentration of impurities to be converted into calcium carbonate equivalence of hardness. So temporary hardness is due to bicarbonate ions, and we get the calculation like 7.3 into 100 by 146 is the molecular weight of magnesium bicarbonate, plus 16.2 into 100 by 162 is the molecular weight of calcium bicarbonate, and we get 15 ppm, which is responsible for the temporary hardness. The permanent hardness, 13.6 for the calcium sulfate and 9.5 for the magnesium chloride, and divided by 100, multiplied by 100 by 95 is the molecular weight for that particular salt, and is equal to 20 ppm, that is permanent hardness. So temporary and temporary and permanent together will give the total hardness for that sample, and we get 15 plus 20, that is 35 ppm is the total hardness that is present in that particular water sample. If we see, compare these two values, similarly, like very slightly high chlorides and sulfates are present. So therefore, even the removal of temporary hardness is also very necessary through boiling or any other treatment too, because it is present almost equally. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.